Now let's go through an example of log mining, which will also be the application in Lab 1. So in this example of log mining, we are going to see how Spark will load the error messages from a log into memory, and then interactively search for various patterns. So suppose we have a driver program and we have like 3 workers. And after having the Spark session object, which is Spark, and suppose the first line, we use Spark session to read a file which is in the address of HDFS, which is a Hadoop file system. And this line defines the base RDD. And then the second line saying errors equals to lines filter, and filter what? Filter the rows starts with error, right? So that means we are going to find the error messages, right? So filter is a parallel transformation. And then these errors will be a transformed RDD from the RDD, which is lines. And then we proceed the next line of code saying messages equals to error dot map. So map is another transformation. So basically we will map the errors to what we are going to do is to do split, right? Split by tabs. Okay? We are going to split by tabs, and that is trying to parsing, right? So trying to parse the error messages. And the next one is something very unique to Spark, which says messages cache. Right? Messages cache. And this is a very important functionality in Spark. Right? So what it does is to store the data. Right? But you may notice here, it remains the same, right? So nothing happens over here, right? So let's see the next line of code saying messages filter what? Filter MySQL. And so that is to say that we want to find those error messages related to MySQL, right? So MySQL error messages. We are looking for this type of error messages, and dot count, right? Count means to count how many messages are there. And this count is an action, right? So it is not a transformation, it is an action, right? So this action will trigger action, right? So when we process to this line of code, we see an action, then the drivers and workers will start to work, right? So basically, let's label worker 1 as block 1, 2. This is block 2, and this is block 3. And so when this one action is processed, there are many things going on. So basically, the driver will distribute the tasks to these 3 workers. And then these 3 workers will start to process those kind of transformations, right? So they, until this line of code, right? So the workers will start to process these lines to read the HDFS block, right? So they will do it in parallel, and then process the individual block. And so they will process it by doing the filtering to find those error messages, split it into different messages, and then filter it to find those MySQL, right? So at the same time, they will cache, right? They will cache the data. They will cache the data, right? So they will cache the data at the worker, right? So each worker will cache their individual data. And then after they process this, find the result, that is the count of how many MySQL errors, they will send their individual results to the driver, right? To the driver, and the driver will aggregate the results. Why Spark want to do this, right? So why until this point, right? So it start to work, and why we do the cache. That will be obvious. For example, when we want to find another type of errors, for example, PHP errors, right? We want to find PHP errors in the log, then we do this filter PHP and count, right? So this is another action. Look at what will happen now, right? What will happen now? The driver will distribute the task, say, hey, workers 1, 2, 3. Now count the PHP errors. Notice the difference from the previous count. Now each worker already have a cache of the data, right? So then they will not go to fetch the data from the file system, HDFS. And so they will just process the data from cache. What is cached? The messages are cached, right? So therefore, each worker will just process from the cache the messages, right? The splitted parse messages to find the PHP errors, and then send the individual results back to the driver, which will aggregate the final result, final count. Right? So therefore, this cache here is a very important functionality, right? Very important functionality to cache the data. Cache the data will lead to faster result, especially if you are processing the data multiple times, doing multiple queries. Right? So if you know the computer hierarchy, it will be very slow when you fetch the data from the disk, right? But if you cache the data in your memory, in your RAM, it will be very fast, right? It will be very fast to process, right? So we will go into more detail in the next lecture, right? So for example, in full text search of Wikipedia of 60 gigabytes on Amazon Amazon cluster, it will take only half a second when we cache the data in memory. But if you have to read the data from disk, it will take 20 seconds. Right? So this is an example of Spark and showing a very important functionality of cache, right? Cache the data. So that finished our simple log mining example. And our next part will talk about how to use Spark.